NOAA's own August discussion contains a number almost nobody quotes. Subsurface temperature anomalies in the equatorial Pacific have reached plus 10.0 degrees Celsius at depth. The surface reading in that same document is plus 1.4. That gap is not an error. It is a reservoir of heat that has not been spent yet, sitting underneath an El Niño that has not peaked. In the next 20 minutes, you will understand why the strongest El Niño in the modern record is still getting stronger and what the next 4 months are likely to look like. 4 days ago, on August 21st, a group of climate scientists led by James Hansen published a communication with a deliberately unserious title and an entirely serious argument. It is called Super Duper El Nino and the Bigger Problem, and it was written by Hansen along with Pushkar Karecha, Dylan Morgan, and Jason Vest. It went out through Hansen's Columbia University mailing list and through his newsletter. The opening claim is 1 sentence long, and it does not hedge. The El Niño now developing in the equatorial Pacific is already the strongest in the modern instrumental record. Not forecast to be, not on track to become. Already is. And the reason that word matters is the timing. El Niño events peak in the late autumn and early winter of the northern hemisphere. We are in August. The event has reached record status with its maximum effects still several months in the future, which means the question is no longer whether this becomes a historic event. The question is how much further it climbs before it stops. Now, if you have been following the sea surface temperature numbers that get quoted in the news, you may be confused right now because those numbers do not look like a record. That confusion is not your mistake. It is the entire story. Hansen's group is not measuring the ocean the way you have been shown it. And once you understand what they are measuring instead, the last 3 years of climate headlines start to read very differently. Here is the distinction that everything else in this story depends on. When you see an El Niño number in a news report, you are almost always seeing a sea surface temperature anomaly. It is the temperature of the top layer of the ocean in a defined box in the Central Pacific, compared against an average. That is, the skin of the ocean. It is what satellites see, it is what gets mapped in red and blue, and it is what the public has been trained to watch. Hansen's group tracks something else. They track the heat anomaly in the upper 300 meters of the equatorial Pacific, across a band running from 180 degrees west to 100 degrees west. That is not the skin. That is the reservoir underneath it. The entire volume of warm water staged below the surface waiting. By that measure, the 2026 event has already exceeded the 1997-98 Super El Niño. That event has been the benchmark for nearly 3 decades. Every El Niño since has been graded against it. It has now been passed in August by an event that has not peaked. And Hansen's group is explicit about why they prefer the deeper number. Both metrics matter physically. Ocean heat content matters because that is the heat that gets exhaled into the atmosphere. Skin temperature matters because it drives the wind feedback that makes an El Niño amplify itself. But sea surface temperature, in their words, is affected more by global warming than the 300-meter heat is. The surface has a fingerprint on it that does not belong to El Niño. The subsurface signal is cleaner. So when the surface says moderate and the reservoir says record, both instruments are working correctly. They are simply measuring 2 different things, and only one of them tells you how much fuel is loaded. There is a figure buried in NOAA's own monthly discussion that almost never leaves the technical literature, and it is the single most alarming number in this entire story. On August 13th, the Climate Prediction Center issued its regular ENSO diagnostic discussion. The alert status is El Niño Advisory. The July index values are in there. The Central Pacific box at plus 1.4 degrees Celsius. The Eastern box at plus 1.7. The Far Eastern box off South America at plus 2.9. Those are the surface numbers. They are elevated, but on the traditional scale, plus 1.4 is a moderate to strong event, not a record one. Then, in the subsurface section, the discussion reports that equatorial subsurface temperature anomalies reached plus 10.0 degrees Celsius at depth. 10 degrees, not 1.4. 10. That is not a basin average, and it is not a global average. It is a localized anomaly inside the subsurface warm pool as it gets pushed eastward along the equator. But it is an order of magnitude larger than any surface anomaly in the same document, published by the same agency on the same day. And it is the reason the 2 accounts of this event diverge so sharply. The heat is there. It has simply not been spent yet. That same discussion also describes the atmosphere responding. Low-level westerly wind anomalies and upper-level easterly wind anomalies stretched from the western Pacific across to the east-central Pacific. Rainfall and convection increased from the central to the eastern Pacific and were suppressed over Indonesia. The southern oscillation indices sat near 2 standard deviations negative through July. Those are textbook signatures. The ocean and the atmosphere are locked together and pulling in the same direction. To understand why a record subsurface number with a modest surface number is genuinely dangerous rather than reassuring, you need about 90 seconds of mechanism. Under normal conditions, trade winds blow from east to west along the equatorial Pacific. They push warm surface water toward Indonesia, piling it into a deep, warm pool on the western side of the basin. On the eastern side, off South America, cold water rises to replace what was dragged away. The boundary between the warm surface layer and the cold, deep water, the thermocline, tilts steeply, sitting deep in the west and shallow in the east. When those trade winds weaken, the pile collapses. All that warm water sloshes back east as a subsurface wave, the thermocline flattens out, the cold upwelling shuts down, and the eastern Pacific surface warms. The warmer surface weakens the trade winds further, which lets more warm water move east, which warms the surface more. That self-reinforcing loop is called the Bjerknes feedback, and it is why El Niño events accelerate once they get going rather than settling into equilibrium. Between events, the subsurface reservoir recharges. During events, it discharges into the atmosphere. That is why the upper 300-meter number is the more physically meaningful measurement. It tells you how much is loaded. The surface number tells you how much has already been fired. A record reservoir sitting under a moderate surface reading means most of this event's energy has not yet been transferred into the air. The transfer typically peaks in the October to December window, which brings us to the number the Climate Prediction Center actually put in writing. The Climate Prediction Center's August discussion carries two probability statements, and the second one is the one to remember. The first, a greater than 90% chance of a very strong event during Northern Hemisphere fall and winter of 2026 into 2027. That alone would make this a significant season. The second is the one that matters. During the October to December season, the center assigns a 69% chance of a historic event, one that would exceed the strength of every El Niño dating back to 1950. The threshold they set is a 3-month index value of plus 2.5 degrees Celsius or greater. Read that again because the phrasing is precise and agencies do not use the word historic casually. Roughly 2 out of 3 plausible evolutions from here produce the strongest event in 76 years of records. 1 out of 3 does not. That is a strong signal and it is not a certainty, and the center says so directly in the same document. Its exact words: with an event of this magnitude, the chances of experiencing impacts consistent with El Niño are larger, but they are not guaranteed. Both documents agree on the timeline. Hansen's group notes the event will continue running for another 9 months to a year. The Climate Prediction Center places the historic window in October through December. Nothing about this has peaked. Everything measured so far is the loading phase. Now here is the fact that reframes everything, and it is the reason this story is worth 20 minutes of your time rather than a headline. You remember the temperature records of 2023 and 2024, hottest year on record, then hottest year on record again. Month after month of records broken not by hundredths of a degree, but by margins that made climate scientists visibly uncomfortable in interviews. Ocean surface temperatures that ran off the top of the chart. The 4th global coral bleaching event. That period was driven in large part by an El Niño, by Hansen's subsurface metric that El Niño was moderate. Not strong, not super. Moderate. If a moderate El Niño, arriving on the planet as it existed in 2023, produced the most alarming run of global temperature records in the instrumental era, then the honest question is what a genuinely record-scale El Niño produces on a planet that has warmed further since. And that question has no clean historical answer, because there has never been a record El Niño on an ocean this warm. The comparison cases do not exist. The 2 closest analogs both landed on measurably cooler planets. The 1997-98 event temporarily lifted global air temperature by roughly 1.5 degrees Celsius at its peak, against a more typical El Niño contribution near 1/4 degree. NOAA put direct global economic damage at $35 to $45 billion. Peatland and agricultural fires burned across Sumatra and Kalimantan and produced haze across Singapore, Malaysia, and Thailand. More than 20 million people reported respiratory problems. That single event is estimated to have killed roughly 16% of the world's reef systems. The 2015-16 event triggered more than $5 billion in humanitarian appeals across nearly 24 countries and affected more than 60 million people. The Amazonian drought and wildfire episode that came with it has been costed at roughly $26 billion. Both of those are useful. Neither is a template. They are what this mechanism does on a cooler baseline, and the baseline has moved. If you want proof that this event is not a forecast, but a thing already changing weather, look at the Atlantic hurricane basin, thousands of miles from the anomaly. NOAA's August update kept its below-normal Atlantic hurricane season forecast in place and named the cause directly, strengthening El Niño increasing wind shear. The updated numbers call for 7 to 13 named storms, 2 to 6 hurricanes, and 0 to 2 major hurricanes. The agency puts a 75% chance on below-normal activity, 20% on near-normal, and 5% on above-normal. That is a downgrade. The late May outlook had called for 8 to 14 named storms, 3 to 6 hurricanes, and 1 to 3 majors. The forecast moved down because the El Niño forecast moved up. The mechanism is well understood. Enhanced convection over the central and eastern Pacific alters the upper-level flow across the tropical Atlantic and increases vertical wind shear. Shear tears apart the vertical column a developing tropical cyclone needs in order to organize. A storm that would have intensified in a quiet year gets sheared open instead, and the season so far matches. 2 named storms, Arthur and Bertha, 0 hurricanes. The climatological September peak is still ahead of us, so this is not the final word. But an Atlantic this quiet in late August, in the era we are living in, is a signal. The Pacific is riding on a basin it does not touch. Here is where Hansen's communication turns, and where it stops being about El Niño at all. The second half of that document argues that the El Niño is not the story. The story is what the El Niño is landing on top of. His group's position is that Earth's energy imbalance, the difference between the energy the planet absorbs from the sun and the energy it radiates back to space, has roughly doubled and is not declining. Their framing of the abstract is blunt. The increasing climate anomalies, the poleward shifting of climate zones, the rainfall extremes, the faster flash droughts and fires, and the marine heat waves are the result of accelerating human-made global warming. And then, the line that got the attention, the abnormal El Niño strength, is itself likely human-driven. They track marine heat waves as part of that case. Those events have increased over the past century in response to warming, and their intensity has recently been increasing faster, in step with the acceleration Hansen's group is arguing for. They also tend to be most extreme in summer when the ocean's surface mixed layer is at its thinnest and the winds are at their calmest, which is to say, the heat gets concentrated into the shallowest possible layer at exactly the moment there is least mixing to carry it away. They also note something that gets lost in global average reporting. Temperature change over land is roughly twice as large as over ocean. Land temperature reached plus 2.4 degrees Celsius relative to the 1880 to 1920 baseline during the 2023 to 24 El Niño. In Hansen's group projects, it is likely to approach plus 2.7 degrees in 2027, almost 5 degrees Fahrenheit. Most people do not live in the ocean. The land number is the one that describes the world you walk around in. Now, intellectual honesty requires me to draw a line clearly here, because parts of this argument are contested and parts are not. The energy imbalance measurement is not seriously contested. It is observed 2 completely independent ways, from space by satellites measuring incoming and outgoing radiation, and in the water, by the Argo float array measuring how much heat the ocean is storing. Those 2 systems share no instruments and no assumptions, and they agree. Norman Loeb, who runs the satellite radiation program at NASA Langley, described that agreement this way. The 2 very independent ways of looking at changes in Earth's energy imbalance are in really, really good agreement, and they're both showing this very large trend, which gives us a lot of confidence that what we're seeing is a real phenomenon. Peer-reviewed work has since found that imbalance more than doubled in recent decades. What is contested is Hansen's next step. His group argues the warming rate stepped up from about 0.18 degrees Celsius per decade across 1970 to 2010 to at least 0.27 degrees per decade since 2010, driven substantially by the decline in sulfate aerosol emissions, including from tightened sulfur limits on marine shipping fuel, which removed a reflective haze that had been masking some warming. They also argue that climate sensitivity is higher than the IPCC's best estimate. Those are published serious positions from a group with a long track record. They are also not consensus. A significant part of the climate research community argues that recent warming falls within the range that screened model ensembles already project, and that declaring a statistically robust acceleration from a record this short is premature. That disagreement has been running publicly for years, in journals and in the open sometimes, sharply. I'm telling you that plainly because you will see this story reported in both directions this week, and you should know which parts are measurement and which parts are argument. There is one piece of the story that is not a projection, not a probability, and not a contested attribution. It is an administrative fact with a date on it, and I think it is the most concrete thing in the entire file. In February of this year, the Climate Prediction Center formally replaced the index it uses to monitor and track El Niño. The traditional Oceanic Niño Index was retired in favor of the Relative Oceanic Niño Index. That is the first change of this kind in roughly 75 years of the classification system. The stated reason is technical and specific. The traditional index measures a departure from a fixed 30-year average, and a fixed baseline, in the agency's own framing, struggles to keep pace with anomalous changes in tropical sea surface temperature, especially in real time when the climatology being used is already time-lagged. Translate that out of agency language and it says something uncomfortable. As the tropical ocean warms overall, the threshold for declaring an El Niño got progressively easier to clear, and the threshold for declaring a La Niña got progressively harder. The ruler was drifting away from the thing it was invented to measure. Eventually, the index could no longer reliably tell the difference between El Niño and a warm ocean. The replacement works differently. Rather than comparing the El Niño region to a fixed historical average, it compares that region against the global tropics as they are right now. That removes the background warming trend from the signal by construction. And the practical effect, in most cases, is that it dampens the apparent strength of El Niños and amplifies the apparent strength of La Niñas. Hold that thought, because it changes how you should read the headline probability. The Climate Prediction Center's 69% historic event figure is stated in the new index. The agency is grading this event on a scale that has had global warming deliberately subtracted out of it, a scale specifically designed to make El Niños look smaller, and it still comes out at 69% odds of the strongest event since 1950. There is a claim circulating online that the index was swapped to manipulate the record. The data does not support it, and it fails on its own logic. A change that makes El Niños look weaker is the opposite of what a scare-them motive would produce. The methodology and the rationale were published openly, and the historical series was recomputed transparently so anyone can check the old values against the new ones. The uncomfortable reading is the correct one. The index was changed because the ocean changed, and the new, more conservative index still says this event is potentially historic. All of this is abstract until it reaches a body or a harvest. So let us go there, because the research that landed this year on that question is genuinely new. A study published this year in Lancet Planetary Health by Kong, Ficelio, Huber, and colleagues did something that had not been done at global scale before. It took laboratory-tested heat tolerance limits, the actual measured conditions under which a human being can no longer hold a stable core body temperature, and it broke them out by age, then mapped them against population and climate projections. Hansen's group cites it directly. The finding is stark. For adults aged 60 and above, the conditions at which thermoregulation fails are roughly 4.7 to 7.5 degrees Celsius lower than for young adults. The same afternoon, in the same city, is a physiologically different event depending on how old you are. At approximately plus 1.5 degrees Celsius of global warming, which is roughly where we are, 22% of the world's population over 60 is already exposed to unsafe temperature levels for at least 1 month a year. And here is the most portable number in this entire story. Each additional degree Celsius of global warming adds roughly 1 month of intolerable heat for 1 billion people. 1 degree. 1 month. 1 billion people. That is the conversion rate. This inverts how heat risk is normally communicated. Public messaging is built around absolute thresholds: a temperature, a heat index reading, a wet bulb value. This research says the threshold itself moves by several degrees depending on who is standing in it, and the world's population is aging at the same time the afternoons are getting hotter. Europe is the live demonstration. Hansen's communication, written 4 days ago, cited reporting of European excess deaths already over 25,000 and rising. In the days since, the tallies have been revised upward. The Euromomo monitoring platform is reported to estimate more than 32,000 excess deaths between mid-July and mid-August. An AFP tally across 8 countries, Austria, Belgium, England, France, Germany, the Netherlands, Portugal, and Spain, reached roughly 33,000 excess or heat-linked deaths for periods running from late May through August. Treat every one of those figures as provisional, because they are. England has recorded 2,877 heat-related deaths across the May and June heat waves, and authorities have said the full-year total will be higher. Belgium recorded 2,570 excess deaths between the 18th of June and the 17th of July. For scale, the 2022 European heat season produced an estimated 61,672 heat-related deaths. 2026 is so far below that. But notice what that comparison actually tells you. This was not Europe's worst summer on record, and it still produced tens of thousands of excess deaths. You do not need a record-breaking heat wave to produce record-scale mortality. You need an ordinary bad summer applied to an older population, and the same event is now moving toward the harvest. A briefing published in June by the Welthungerhilfe, Anticipatory Action Facility, synthesizing forecasts from FUSE-NET, the UK Met Office, The World Meteorological Organization coordination mechanism and the regional crop monitors laid out where the dry signals fall. Across the greater Horn of Africa, below normal rainfall probabilities exceed 60% over substantial areas and peak at 80% in Ethiopia and South Sudan. Across South Asia, drier than normal conditions are most likely over large parts of India, Pakistan, and Nepal, with the strongest dry signal over Indonesia and Papua New Guinea, which raises wildfire risk. The exposure that concerns forecasters most is not this month. Southern Africa grows a single maize season running December through March. That window lands precisely on the forecast peak of this El Niño. The same briefing carries a caution I want to quote directly, because the forecasting community itself is asking for restraint here. The term super El Niño, it says, should be used cautiously. The evidence supports a high likelihood of El Niño and a significant possibility of a strong event, but not guaranteed severe impacts everywhere. A strong El Niño is a loading of the dice. It is not a script, and some regions on that risk map will come through this fine. So where does this leave us, and what are the actual checkpoints? The first one has a date. The Climate Prediction Center's next ENSO diagnostic discussion is scheduled for September 10th. That document is the first real test of whether the 69% historic event probability for October through December holds, climbs, or backs off. It is a specific product on a specific day, and it will either confirm or complicate everything in this report. The second thing to watch is whether the surface catches up to the reservoir. That gap, a record subsurface heat anomaly sitting under a plus 1.4 degree surface reading, is the unresolved technical question in this whole story, and it splits into two very different futures. If the surface climbs toward the subsurface signal through autumn, then the straightforward reading is right. The heat is staged and about to be spent, and the visible impacts escalate sharply into 2027. If the surface does not climb, then the relationship between subsurface heat and surface response has changed on a warmer planet, and that is a larger scientific story than this El Niño. The third is the harvest window. Southern Africa's planting season begins as this event peaks, and no outcome is knowable yet. The first hard data will not exist until the rains either arrive or they do not, and underneath all three sites, the argument this entire report has been circling. Every El Niño in living memory eventually ended, and the world came back to something recognizable. The reason this one is being covered differently is that the recognizable thing may have moved. The peak is what gets the headline. The baseline is what decides what the peak means. We covered a study on this channel on the 14th of August about the Atlantic overturning circulation, and its central finding was that the deciding variable was not how much the planet warmed, but how fast. That a slow ramp let the ocean adjust and a fast one did not. Hansen's argument here is structurally the same argument in a different system. The number that matters is not degrees. It is degrees per decade. We will be tracking this straight through the autumn. The next hard checkpoint is September 10th, and if the subsurface heat starts moving to the surface in the weeks after it, you will feel this event long before you read about its peak.